Hey guys and girls, welcome to a new clip in the C# for Beginners playlist. In C# we have two major concepts that allow us to implement OOP, classes and structures. And while we know that classes are implemented using the class keyword, for structures we use the keyword struct, as we will see in a moment. And the main difference between classes and structures is that classes are reference types, while structures are value types. In terms of stack versus heap, both classes and structures go on the heap if they are declared as fields, because they need to be allocated as part of the memory needed by that instance. But when we talk about local variables, while classes still go on the heap because they are reference types, structures hold their members entirely in the program's execution stack, unless they are captured in closures or they are part of async iterators or other advanced concepts that I'm not going to get into. But for all intents and purposes, local structure instances are allocated on the stack, and that has great performance capabilities. Let's take an example of defining a structure using the most popular struct in the entire .NET, the 2D point, which has an X and an Y coordinate. As you can see, this is identical to a class, with the only noticeable difference of using the struct keyword instead of the class one. But other than that, they are identical. And because point2d is a struct, which means a value type, this means that its instances will behave like int or double and so on. And also because it's a value type, this means it's not nullable unless we explicitly mark it as nullable, as I explained in the video about nullability. And also because it's a value type, if we take it as a parameter in a method, it is passed by value, as I explained in the stack versus heap lesson. To illustrate this, let's play a bit with the point2d structure. This example demonstrates the fact that the structure is a value type, because when we use it as parameters to a method, its fields are copied the same way an int parameter is copied when we call a method with it. So we declare a point2d structure with the values 3 and -2, we print its values, then we send this instance to a method inside which we increment its fields. Then we print the values again, but as you can see, they don't change, because when we call this method with this instance, we are actually making a copy. Its fields are copied inside this new point2d structure, which means when we increment its fields, we are incrementing the fields of this copied instance, not of the original one, which remains unaffected. But if we change it from a struct to a class, the result will be very different. As you can see, the value is changed. That's because when we send the structure, again, its entire fields, its entire values are copied into a new structure. But when we use a class, since it's a reference, we still pass it by value. Don't make that mistake to think it's by reference. We still send it by value, but what's copied is the reference itself, not the object itself. So the reference is copied, but it still points to the same heap object. For you as a beginner, probably the hardest question right now is when to use a class, when to use a struct, since they are so similar. And aside of the fact that they behave slightly different, like you just saw, my recommendation is that if you have data structures that have fields that come together and they are simple, like coordinates, locations, sizes, colors, etc., use a struct. Obviously, use a struct if you need pass by value semantics, like you just saw. You will also hear the advice that you should not have functionality inside a structure. And that's a bit misguided, because if we go to the definition of an int, you will see that there is plenty of functionality inside it. So it's not about not having functionality, it's about not having unrelated functionality. If we were to inspect the functionality inside the int, you would see that everything is focused, is centered around the value that an int stores. But for example, if I have an invoice, I have a method to calculate the total, yes, but I also have a method to sort the list of products by quantity. What do they have in common? Nothing, other than the invoice needs both of them. So it's about if you have functionality that needs to be there but is not related one to another, then you should use a class. I would not use a struct for my invoice. You should definitely not choose a struct just because it's allocated on the stack and it's faster, unless you really know what you are doing. As their name suggests, structure, they are used for structured data. They really are centered around this concept of data. But we already have classes, and we will learn soon about records, which are also aimed at storing data. So the only remaining real reason to use a structure is that by value behavior that you noticed. So when you do need it, that's when you should use a structure. That was all for today, and I really hope this clears the difference between classes and structures, because it's really not that hard. Anyway, don't forget to like and subscribe, and for now, thank you for your time and for watching, and I'll see you in the next tech frame.